Hi guys, welcome to another video. Um, so many of you guys asked me how to interpret SwiftUI code and how it actually works. Uh, I think a basic project just to explain how SwiftUI actually works and how to think about making an app in SwiftUI will be beneficial. So let me make a sample SwiftUI app without core data because we're just gonna have very basic functionality like uh, property wrappers and how to use property wrappers, how to use state to make app functionality. Some of you asked like why we need all these at stuff like at state, at binding, and at observed. So I'm going to explain all that stuff here. So just to start off, uh, because we are making an app, we need an entry point in our code. So we need a at main uh, decorator here to tell SwiftUI that this struct sample SwiftUI app, and that would be the main structure that will represent our app. So it's nothing but a simple structure that follows the app protocol. So we are saying that this structure is our app essentially. And then as the app body, what we are saying is our body is actually a scene in the app. So scene is kind of the app's visible area. So wherever your app is shown on the screen, that's a scene. So our body of the app is going to be some scene. And in that scene, what we define window group to say that this is one type of window that will be represented on the screen through our app. And in that window group, uh, we will have one content view that will actually lay out our app. So this is that content view file. So we declare our structure content view, and it follows the view protocol because similar to this structure that was our app, now we need some views to put on the screen. So our content view that is inside the window of the app will follow the view protocol. And because it follows the view protocol, its body, so body is a computed property here of this structure content view. So body of this guy will contain some view. So similar to our app structure, where our app body was a scene, our content views body will be some view. And here let me just continue the simulator so it loads in the meantime. And in the body, what we are saying is that it should lay out a text view that has the string hello world and padding around it. So for now, we will ignore this content view preview and what it contains. Just know that this is the piece of code that's displaying the preview on the right side. We will focus on our body of the content view, that is some view. It has a text view and some padding around it. As you can see, it has a hello world text view and it has some padding. So let's remove the padding for now, and we can see that it doesn't have any spacings around hello world. But when we add padding, now it has a spacing around it. So there's a buffer area around hello world. So what we are going to do is pretty simple. We will just lay out one more button just below the text view, and when we press that button, the text hello world is going to change to something else. So let's say I love SwiftUI or something. So for that, let's create a vertical stack. So you just, for creating vertical stack is simple. You type v stack and then open and close curly braces, and that is your vertical stack. And we want to put our text view inside the vertical stack, and then just below the text with the padding, we will have our button. And to create a button, just say button, open the parentheses, and let's choose this action and label template. And when you enter, you see two enclosures here, one for the action of the button, that's this one, first one, and one for the label of the button that would be shown on the screen. So for the label, we will just have a text that will say tap me, and for the action, we'll have to toggle some variable so that we can store if we are going to show hello world or I love SwiftUI. So let's create a boolean variable. So we'll create a var, say is let's say showing hello world. Okay. And then for now we'll make it false, and this is a boolean. Just to make it explicit, we can say we have created a variable that's a boolean, is showing hello world, and it's currently false. So when the app starts and this structure loads, the initial value will be false. And actually in this case it's true, so make it true. So initial value will be true, it will be showing the hello world. But now what we want to do on tap is when someone presses the text tap me, then we are going to make it false or invert it. So generally you invert like this, just take the inverted value of the same variable. But this in SwiftUI, this is in Swift rather, because Swift has the toggle function on the bool. So let's say just dot toggle, so this will just toggle that variable bool. It's a Swift function, not a SwiftUI feature. But now it says that we cannot mutate the member is showing hello world because self is immutable. As you remember, in structures you cannot mutate a member. So if we are going to change this is showing hello world, so essentially we are changing the content view, because it's showing hello world is a member of that structure, and structures gotta be rigid. So by default structures are rigid. So if you're changing any of the properties that you have already assigned, it's gonna complain because structures don't want any changes. Let's leave this as it is for now, and also now change our text view to show different text for different value of is showing hello world. So we will use a tertiary operation. So we'll just say ask if is showing hello world is true. If it is true, just use the value of hello world, or else use the value I love SwiftUI. So this is simple. It's just a tertiary operation to choose one value or the other. So if you compile, this is the only problem that's remaining. One way to solve this would be to make this variable as a global variable instead of inside the struct, and that way we can toggle this. So let's resume our preview, and let's tap on the button tap me. So as you can see, let's first run the preview, and if I tap the button, as you can see, nothing happens, and that is because this structure is not changing. It's not to say that its variable is not changing, it's just that SwiftUI never redraws a view if nothing has changed. If you think about how SwiftUI works, it's not that SwiftUI is drawing this content view on the screen every time, like 60 frames per second. That's not the case. It's not drawing at 60 frames per second. It's not drawing even at 1 frames per second. It's not drawing at any frequency. It just has drawn it once, it forgets about it. Like, it has no work to do after it has computed this body once and put it on the screen. So SwiftUI just draws it one time and it's done, unless you specify to SwiftUI that whenever this variable changes, we need to redraw this body. To tell that to SwiftUI, we use @state. That's a property wrapper. So if you go back to when our variable was inside our structure, if we mark this variable with the state word, so its state is a property wrapper, just put it just at the start of the variable. And now when you compile, as you can see, now it no more complains about a structure being modified when you toggle the state, because we have explicitly told SwiftUI that we actually want to keep changing this variable. So we have marked this with a state property wrapper. It's similar to, if you know about structure, right? It's similar to this mutating keyword in the function. So let's say we have a function called toggle, and if you mark it with mutating, then you can change any state, any variable that is. So even if we don't have the state, if we try to compile, the only complaint is here, not here, because we have explicitly told Swift that this function can change the properties of the structure. So similar to this mutating keyword, we have this property wrapper state that you mark your property with, and you can change this variable anywhere inside the structure. And also, at the same time, this state variable tells SwiftUI that it has to watch for any changes to this variable, and if this variable changes, then it has to recompute the body, because depending on this state, something must have changed in the text view, either the button or anything inside this body. So that's the use of state. So it tells the SwiftUI that it has to watch for this state inside the view, and if this state changes, it's very likely that something needs to be redrawn, because something must have changed on the screen. It might not have been changed, but still SwiftUI needs to redraw it just in case it has changed. So if you resume our preview, and now if you tap on it, you can see we are changing between hello world and I love SwiftUI. So SwiftUI is not drawing this body 60 frames per second. It only draws when this variable that is marked with the state changes. So when you tap on it, in the action we are toggling this variable, and this variable is changing, it redraws the body, and when it reaches here, it says that it has been turned to false, and if it has been turned to false, I need to use this string in the text view. So it redraws, changing the string. So you can see this if I run this on the simulator. So we will run this app on the simulator, and we'll put some breakpoints here inside the body. And let's see when it gets triggered. As you can see, it got triggered right now. And if I continue, now our view is drawn on the screen, and as you can see, now it's not being triggered. So once it has drawn the body, now it's done. It's not drawing it at any frequency. It's just waiting for any change. It's just waiting for any changes to happen in this state, because we have marked it with @state property wrapper. So if you click on anywhere, like nothing happens. But if you tap on this button, which will in turn change this state, will re-trigger the computation of this body for the content view. And once that happens, as you can see, the text has been changed. With the breakpoint here, it's the same thing. Comes here, it has been changed. Good. So that's the role of @state inside a view. So this is called a transient behavior, because it's related to just one view and not the whole app, right? You could have multiple such views inside your app, and then this tap me button will just be local to this content view. So if something is local to this just one view, you just represent that state, that variable, with just a state property wrapper, so that this state is contained in this view. So when you change this variable, anything that is showing on this view screen is going to change, nothing else in the app. So if you have multiple views in the app, no other views are affected, only this view will change. So if you tap me, just the text view inside this screen is going to change. So similar to this state, you have many more property wrappers that you can look into. So one is observed property wrappers, generally used for models. So models are like app level data that you want to maintain and observe. So if the model changes, many such views can take input from the data model, and according to the changes in the data model, they will update their UI. So that's not transient, because that's not related to just one or two views. It's related to many views. So that's why we use a different property wrapper at observed for that. That's just to let SwiftUI know to optimize stuff under the hood in such cases.